Hello viewers, here's an example on logistic goods model. The population of flies in education follow the logistic model. P of t is equal to 438 all over 1 plus 35.5 exponential to the power of minus 0.140, where t is measured in days. What is carrying capacity and growth rate? What is the initial population? How many flies will be present after 1 week? We have to find the carrying capacity and growth rate, number one. So here, according to the logistic model formula, we generate that P of t is equal to m all over 1 plus a exponential minus kt in my previous lesson on logistic growth model. So in this case, m is our carrying capacity while our k is our growth rate. Our p is population at the time and our t is what? The time or the period. Our m is equivalent to 438 as our growth rate. Our k is equivalent to what? 0.140 as our what? Growth rate, while our m is equivalent to what? 438 as our carrying capacity. So our carrying capacity will now be carrying capacity is our m, which is what? 438, and our growth rate will be 0.140. This negative, it has been a constant before when we generate the formula. So the growth rate is not negative 0.140, it's 0.140 because our growth rate is a constant form. We generate this negative from when we are solving the logistic model equation. So what is the initial population? So the initial population. So since our initial population, initial population is what? The starting point, the starting time. Our starting time is our initial. So it means our t is equal to 0. Our t is equal to 0. What is our population of the flies? So we now have p of t is equal to our m is what? 438 all over 1 plus 35.5 exponential minus 0.14. Our t is 0 here. Now P of t is equal to 438 all over 1 plus 35.5 exponential to the power of 0.140. If you multiply this by this, we are going to get 0. So we now have 35.5 exponential 0. So our P of t is equal to 438 all over anything raised to power 0, we are going to get 1. So if you multiply 1 by this, we are going to get 35.5. 1 plus 35.5, you get 36.5. 36.5. If you divide 438 all over 36.5, you are going to get 12. So our P of t is equal to 12 flies will be present at initial population at t is equal to 0. So our P of t is what? What is the initial population? The initial population of the flies is 12. How many flies will be present after 1 week? How many flies will be present after 1 week? So, how many flies will be present after 1 week? So, where t is measured, our time is what? 1 week. Remember, we have been given our t is measured in days. It means our 1 week must be what? Must be converted to what? A day. So 7 days make 1 week. It means 1 week will be equivalent to what? 7 days. So we now have our P of t is equal to 438 all over 1 plus 35.5 exponential 0.14. So our t is what? 7. So we now have 438 1 plus 35.5 so you have to multiply this by this. 1 plus 35.5 exponential. If you multiply 0.14 by 7, what are we going to get? 0.14 times 7. 0.98. So we now have 0.98. So if you take exponential of negative 0.98, what are you going to get? If you take exponential of negative 0.98, we are going to get 0.37. The number is an irrational number. You have to take it to what? Fourth significant figure. 37 or 4 decimal place 0.3753. So we now have 438 all over 1 plus 35.5 into 0.3753. If you multiply this by this, what are you going to get? If you multiply it by 35.5, what are you going to get? We are going to get 13.2, 13.32354401. So to 2 decimal place, we are going to get 13.32. So we are going to get 13.32. So now P of t is equal to 438 over 1 plus, when I multiply this by this, I got 1 plus 30. 1 is there before, 13.32. If you add 1 plus 13.32, we are going to get P of t is equal to what? 438 all over 14.32. If you divide 438 divided by 14.32, so you are going to get 30.58. So our P of t is equal to 30.58. This is equivalent to what? We are going to get 31. So our flies present after 1 week strike, 31 flies. So how many flies will be present after 1 week? After 1 week is what? 31 flies. You can make a screenshot of this. So next video we'll go to another examples on logistic growth.